Hello everyone, welcome back to another video. So as you have seen the title, today we are going to talk about time complexity. So what is time complexity? So time complexity is a method of estimating execution time. So the execution time, if you have seen, when you run programs, sometimes in most of terminals it will print the execution time. For example, it will print something like 0.34 seconds or 0.05 seconds. So for as a human to estimate this value, it is hard to estimate exactly the time which the program takes to run to execute a program, but we can calculate an entity which is directly proportional to execution time. So that entity is number of iterations. So for that's if you think intuitively, execution time is directly proportional to number of iterations. Now, number of iterations means number of commands which we are running, which we are calling or running in the program or an algorithm. Now, instead of estimating this execution time, we can estimate the number of iterations and try to compare all the algorithms based on number of iterations itself. So time complexity is a method of estimating this number of iterations in worst case scenario or best case scenario. So let's see an example. The most simple example. Let's say this is a simple C++ program and I am declaring an integer n and in taking input as n, and I will also take one here as input. Now if you see the number of iterations here are first one iteration is for declaring integer n and another integer is for taking n as input. So total number of iterations here are 2. Now for representing time complexity, there is an representation called as big O of n, or any formula which is equal to calculate number of iterations. Here it might be O of 2 because just we calculate the iterations and the number of iterations here are constant. Sometimes it may be a formula or anything else. Now if I just also try to print the integer n, so the number of iterations here increases by 1. So here number of iterations becomes 3 and the time complexity becomes O of 3. Now this type of complexity where the uh, the the expression represented in both brackets of O is, if it is constant, then we call this complexity as constant time complexity. Now another base simple example is O of n complexity. Now if I just declare sum, and for each integer I'm just incrementing sum from 0 to n. Now if you see this program, first there are 3 iterations, one for declaring n, second for taking n as input, third for declaring some vector, some integer variable. Now I am repeating this for loop, this command for n times. So for I is equal to 0, it will increment sum, so one iteration for I equal to 0. For I equal to 1, another iteration. For I equal to 2, another iteration. And this will repeat until I becomes n minus 1. And when I becomes n, the for loop exists. So here complexity becomes 3 plus n. So the number of iterations become 3 plus n and complexity becomes O of n plus O of 3. Now Here is another assumption. Let's say n is equal to 10 raised to power 5. Now, if you have studied integration differentiation, you have must have seen this symbol uh, where let's say I have an equation like x plus dx, and we say dx is very less than x. So the overall equation can be written as x. We can, because we can ignore the value of dx as it is very small than x itself. Similarly, in time complexity, here 3 is very less in comparatively to n. So we can ignore the complexity of O of 3, and we can just write the complexity of this program as O of n. And this type of complexity is known as linear time complexity. Now another, let's say I have to take a 2D vector as input, 2D array. So I have to write two for loops for that. If you don't know this matrix, just assume that I am writing two for loops in one another. So here let's start with the first. Let's try to calculate number of iterations which the program makes. So first three we will just ignore because of the, as I explained before, we can ignore this three because the number of iterations made by these two for loops will be way bigger as compared to the first three iterations. Now, as you can see, for I equal to 0, I am making n iterations. For I equal to 1, again I am making n iterations, and this will repeat until I becomes n minus 1, and when I becomes n, the for loop exits. So if you see the number of iterations over here, they are n in n square, because I am repeating n times, so it becomes n into n, which is n square. So complexity here becomes O of n square. So this is again called as, it is called as quadratic time complexity. And there is another one, most means a simple complexity, I can say, but it is harder to observe. So for I will write a while loop, and while n, I will just divide n by 2 until n is greater than equal to 0. Let's start to calculate its try to calculate its iterations. Now if I take n equal to 16, in first iteration it will become 8, in second iteration it will become 4, in third iteration it will become 2, in fourth iteration it will become 1, and then it will become 0. So it took 5 iterations to make n equal to 0. Now if you try to use logically the complexity becomes log 2 of 16. So log 2 basically means its base, uh, we are explaining 2 to the power x greater than equal to 16, and we are just calculating value of x. Value of x here will be equal to 5. So this type of complexity is called as logarithmic complexity. Let me just show you its proof. Now if I just increment counter whenever it goes into while loop and print counter for 16 only, as you can see the output of the program is 5 because it ran the while loop 5 times. Now if I just make it, instead of making this 2, if I make this 3, the complexity will become log of n with the base 3. If I make it 10, it will become log of n with the base 10. But 2 is very common complexity. It is used in binary search or any bits manipulation question, so you should also remember. O of log n, and this is known as logarithmic complexity. Now if you there is another complexity as O of n log n, which is used for binary search questions, and this is called as linear logarithmic complexity, just multiplication of n and log n. Now how to here we are calculating number of iterations, right? We are not calculating the actual execution time of the program. But when you see problems on Codeforces or let's say CodeChef, here the time limit is given in seconds. Like here it is given 1 second, here also 1 second. Let's open a question on CodeChef. Let's just go to, if you see here, time limit is 1 second. So how the time limit given here is in seconds, and we are estimating number of iterations. How to compare both of them? Now there it's the mathematically 1 second takes around 10 raised to power 7 to 10 raised to power 8 iterations. Now this you have to remember always, and if you have to always limit your iterations less than or equal to 10 raised to power 7. Don't also consider 10 raised to power 8 because you might be using some expensive functions in your code. So always try to make it less than equal to 10 raised to power 7 iterations, and your program will run within 1 second, and you will not get TLE verdict. Now in competitive programming, most of the time limits are between, I would say, as long as I have seen questions, it is between 1 to 6, 7 or 8 seconds. It will not never go above this. If you are as a beginner, you should only consider 1 to 2 seconds, and 1 to 8 seconds is given because if you are using means graph or recursive problems, it will take more time, so it's just given as a buffer. So but you should remember the number of iterations you make should be less than equal to 10 raised to power 7 always. So let's just try to analyze one of the problems. Now here we are given t. So in most competitive programming problems, you are given time limit for per test, and in each test there are t test cases, and for each test case the actual problem is given. So let's try to take the input of the problem itself. So I will, for each test I will declare number of test cases as t, and while t is greater than equal to 0, while t is greater than 0, I will take input as, let's say, and we are given input, and I have to take input vector of size n. Now in this question, if you try to calculate uh, number of total iterations, so for each test case there are n iterations, and in worst case there are n iterations, and if you see the constraints, for the constraints are basically maximum and minimum value of t and n, or all the variables which you are using in the problem. So here value of t is 10 raised to power 4 and value of n is 10 raised to power 5. So the number of iterations are 10 raised to power 4 into 10 raised to power 5. So how do you if you calculate total value of this, it will be equal to 10 raised to power 9. Now for 10 raised to power 7 iteration, it takes 1 second. So for 10 raised to power 9 iterations, it will take 100 seconds, but the time limit here given is 1 second. Now how Even if you are taking the input here, the time limit exceeds. But there is also an additional condition given here, which a lot of programmers tend to ignore and don't know the significance of this line. So what here it is written that it is guaranteed that sum of n over all test cases does not exceed 10 raised to the power 5. So let's start with initial step, which is calculating iteration. What t into n represents? It represents the total number of iterations over all, or basically total sum of n over all t. Now if we are given that total sum of over all t is less than 10 raised to the power 5, that means t into n itself is less than 10 raised to the power 5. Now how is that? If let's say t is 10 raised to the power 4, so all the values of n in each test will always be less than equal to 10, and these are the tests which are uh, given by the author itself. So this line limits our this line gives us more idea about the total number of test case, and in each test how many n's, maximum value of n, what it can be. Now what you have to do in this type of questions, I misclicked. So if this line is written, if you don't understand it right now, you will eventually understand as you solve more problems. You have to calculate complexity without considering t if this line is written. Now without considering t means you have to write a solution of, let's say, formula x, where the x should be less than equal to 10 raised to the power 7. Now x can be n log n, or n log n, or it can be n square also, but the worst value of, we have to take worst value of n, which is maximum value of n, and calculate the maximum value of x, and it should be less than 10 raised to the power 7. Now here n log n will work when n value is less than equal to 10 raised to the power 7, and again n log n will work for when n is less than equal to 1 is 10 raised to the power let's say 5, and n square will work if the value of n is less than equal to 10 raised to the power 3, or of any order of 10 raised to the power 3. Now this is the significance of this line, which a lot of programmers ignore. You will eventually learn this how it, I already explained it, but if you don't understand it, still there are no problem, but you have to read the question correctly, carefully, because if this line is written, you have to ignore the complexity including t. Now I will show you another example. Here it is written that there are no constraints of sum on n over all test cases. Here there is some constraint, and here are no constraints on sum of n over all test cases. Now in this question it is written, but in most of question there will be no condition written, like here it is written. But if they have removed this sentence also, we have to consider that there are no constraints on n, sum of n. Now in this type of question we have to also consider the complexity of the involvement of t. So in this type of question, t into complexity of algorithm should be less than equal to 10 raised to the power 7. So complexity of number of iterations the algorithm makes should be less than equal to 10 raised to the power 7 by 500. So x should be less than equal to 2 into 10 raised to the power 4. Yeah, I guess it's correct. Yeah. So x should be less than equal to 10 raised to the power 4. So this was, I guess, I covered everything. Also, I will share my tips about it. So I think there are basically three more special complexities other than this, which I think are important. First is n log n or log n into n. I consider them different because the order of for loops are different. So I'm using n log n means I'm declaring a for loop, and in each for loop I'm using binary search kind of algorithm. So, and second is I'm using first binary search and then a for loop, linear time for loop. This type of algorithm are this type of complexity is basically important in binary search on answer, not normal binary search on answer type of question. If you don't know, means you are probably a beginner, but this is, I think, the most important topic of competitive programming. Second is, I think, 26 into n complexity. So if you try to understand what 26 is just number of characters in alphabet. A lot of questions are there on strings, and strings generally contains lowercase letters or uppercase letters from A to Z, and we have to do some kind of operations, and the operation basically depends on occurrence of a single character, repeating character. So this type of complexity is used in those questions. And other, I think, is 32 into n. 32 means just number of bits in int variable. So int means 10 raised to power 9 value. So this type of question requires bit manipulation. So these are just my observations which I have done while solving problems on Codeforces. You also will come up with these kind of observations as you solve more problems on Codeforces. And I guess I covered all the topics. So still, if you have any doubts, you can just DM me on LinkedIn or just put it in the comment section. I will definitely reply. And thank you for 100 subscribers also. Thank you for watching. Bye.